Good morning, my dear students. In this video presentation again, we will discuss some more problems meant for class 12 of CBSE. The first problem is on integration. I'll move on to the problem directly. Evaluate integral dx by x power 4 plus 1. This is the given one. What I will do is, I'll take x square as common in the denominator. Just multiply x square and x square is x power 4, x square and 1 by x square is nothing but 1. Now I'll take this 1 by x square to the numerator and I'll multiply and divide by 2. I need it, therefore I do. This way. But this 2 by x square can be written as 1 by 1 plus x square, 1 plus 1 by x square minus 1 minus 1 by x square times dx in the numerator divided by x square plus 1 by x square. You just check, 1 minus 1 gets cancelled, 1 by x square plus 1 by x square is nothing but 2 by x square. I'll make it into two integrals now. 1 by 2 times 1 plus 1 by x square dx by this much minus half integral 1 minus 1 by x square dx divided by x square plus 1 by x square. Now, if you observe carefully, here numerator is nothing but derivative of d of x minus 1 by x. You can just check. I can write the denominator as x minus 1 by x whole square plus root 2 the whole square minus half integral, this can be written as d of x plus 1 by x by x plus 1 by x the whole square minus root 2 the whole square. Let me just explain once again. D of x is 1, d of minus 1 by x is plus 1 by x square. I'll write the denominator as a perfect square in this quantity. X square plus 1 by x square plus 2 minus 2 will get cancelled. Similarly, d of x is 1, d of 1 by x is minus 1 by x square. I'll write the denominator as a perfect square in terms of x plus 1 by x. This is x, not u, please. Therefore, this will be half integral du by u square plus root 2 the whole square minus half integral dv by v square minus root 2 the whole square, where my u is nothing but x minus 1 by x, v is nothing but x plus 1 by x. Therefore, this will become 1 by 2 into 1 by root 2 tan inverse u by root 2. Okay, then I'll end up with minus 1 by 2 into 1 by 2 root 2 log mod v minus root 2 by v plus root 2 plus c. Let me just replace the values. 1 by 2 root 2 tan inverse, my u is x minus 1 by x minus 1 by x by root 2 minus 1 by 4 root 2 log mod x plus 1 by x minus root 2 by x plus 1 by x plus root 2 plus c. After taking LCM everywhere, I end up with 1 by 2 root 2 tan inverse x square minus 1 by root 2x minus 1 by 4 root 2 log mod x square minus root 2x plus 1 by x square plus root 2x plus 1 plus c is the final answer. That will be the final answer. Let me just check the book answer. I'll just tilt it a little bit. The bottom portion is not visible. Just see here, let me just check the final answer. 1 by 2 root 2 tan inverse x square minus root 2x minus 1 by 4 root 2 log mod. This much is correct. Let me just explain. Take x square as common the denominator. Multiply and divide by 2 after taking this x square to the numerator. Write it as 1 by x square in the numerator. This 2 by x square can be written as 1 plus 1 by x square minus 1 minus 1 by x square. 1 minus 1 goes off. 1 by x square plus 1 by x square becomes 2 by x square. Make it into two integrals. Here the numerator is d of x minus 1 by x. d of x is 1. d of minus 1 by x plus 1 by x square. Minus 1 into minus 1 at x power minus 2 become plus 1 by x square. I'll write the denominator as a perfect square in terms of this x square plus 1 by x square minus 2 plus 2 will get cancelled. Here d of x is 1, d of 1 by x is minus 1 by x square. 1 by x is x bar minus 1, derivative is minus and x bar minus 2. Remember carefully. I'll make it as a perfect square here in terms of x plus 1 by x. X square plus 1 by x square plus 2 minus 2 will get cancelled. I'll replace this by u, this by v. U is x minus 1 by x. It's the form dx by x square plus a square. Now for 1 by root 2 tan inverse u by root 2. This is the form dx by x square minus a square. 1 by 2 root 2 log mod v minus root by v plus root 2. Instead of u x I have v, the formula. Now for 1 by 2 root 2 tan inverse u replaced by x minus 1 by x. V is replaced by x plus 1 by x. After taking LCM within tan inverse within log, it becomes 1 by 2 root 2 tan inverse x square minus 1 by root 2 x. X is outside the root here. Minus 1 by 4 root 2 log mod x square minus root 2 x plus 1 by x square plus root 2 x plus 1 plus c. That will be the final answer. That will be the final answer. I think it is clear. It is not at all difficult to follow. It is not at all difficult to follow. Understand the steps behind them, behind each and every formula being carried over in every other step over there. It's not at all difficult. You need to just understand thoroughly what formula is being used, what substitution is being used in every other step, and it will be definitely easier. Now the next problem goes like this. Just see here. Let me divide into 3 parts so that it will be easier for you to follow if I write. See here, next problem goes like this. Let me just see. Find the foot of the perpendicular from 1, 0, 1 to the line x minus 1 whole by 1 is equal to y minus 1 whole by minus 1 is equal to z minus 1 whole by 3. Hence find the distance between the point and the line. Also find the image of the point in the line. I'll just show you the question. See, read the question. I'll just show it for a minute or so. Actually, by image we mean it's something like a mirror image. If you go and stand before a mirror door, your image will be there on the opposite side, the same distance. If you come closer to the door, the image will come closer to the door the same distance. If you move away from the door, the image on the opposite side will move away from the door the same distance. Similar to your mirror image, I am supposed to find the image of the given point with respect to the given line. In the line, with respect to line, both will imply the same. Remember carefully. Therefore, once you know how to find foot of the perpendicular, image is also easier. Let me just draw the rough diagram. I will take the given point to be A1, 0, 1. Okay. The given line, let me write the line. In fact, the given line is, let us say, this is x minus 1 by 1 is equal to y minus 1 by minus 1 is equal to z minus 1 by 3. Now, let the given point be capital A 1, 0, 1. Given line is x minus 1 by 1, y minus 1 by minus 1, z minus 1 by 3. Name it as equation 1. Remember carefully. See whether the line is taken properly again. Now general point on 1 is given by, if I equate it to k, general point will be in terms of k. If I equate it to L, it will be in terms of L. If I equate it to lambda, it will be in terms of lambda. Doesn't matter. Therefore, it will become k plus 1 minus k plus 1, 3k plus 1. Let it be. For infinitely many real values of k, the point will keep on moving on the line. Okay. For some value of k, this point coincides with B. What is the significance of B? Where B is the foot of the perpendicular from A to 1. 1 is the given line. Anyway, you know very well, if 2 points capital A, x1, y1, z1, capital B, x2, y2, z2 are given in space in 3D, the drs of the line passing through A and B will be x2 minus x1, y2 minus y1, z2 minus z1. Therefore, drs of line AB or vector AB, either way you can write drs of line AB, or it will be here k plus 1 minus 1. Okay, minus k plus 1 minus 0. Then of course 3k plus 1 minus 1. drs will be written with this kind of bracket. Points will be written with this kind of bracket. Remember carefully. Now for my x2 is k plus 1, y2 is minus k plus 1, z2 is 3k plus 1, x1 is 1, y1 is 0, z1 is 1. This is my point x1 equivalent to x1 y z1. This is equivalent to x2 y2 z2. Now here this will be is equal to k minus k plus 1 3k. Now you know very well two lines are perpendicular if and only if sum of products of components of drs of them will be 0, or two vectors a vector and b vector are perpendicular if and only if a dot b is 0. A dot b is equal to 0 is equivalent to sum of products of components of dr is equal to 0. If a vector is a1i plus a2j plus a3k, b vector is b1i plus b2j plus b3k, a and b are perpendicular if and only if a1 b1 plus a2 b2 plus a3 b3 is equal to 0. Get the product of I components plus product of j components plus product of k components. Therefore, AB is perpendicular to 1. Therefore, by condition for perpendicularity, what do I get? drs here will be 1 minus 1 3. Therefore, k into 1 plus minus k plus 1 into minus 1 plus 3k plus 1 into 3 is equal to 0. Since drs of 1 are, what are they? The denominator will give you drs 1 minus 1 3. Therefore 1 into k plus minus 1 into minus k plus 1, then of course 3 into 3k. No, 3k, sorry. Here I by mistake I wrote 3k plus 1. 3 into 3k I have. 3 into 3k. 3 into 3k. Let me try to simplify this. Let me try to simplify. What do I get? K plus k minus 1 plus 9k is equal to 0. Therefore 11k is equal to 1. K becomes 1 by 11. Therefore point B now becomes, B is replace k by 1 by 11. I'll get 1 by 11 plus 1. Again minus 1 by 11 plus 1, comma 3 by 11 plus 1. That is, after taking LCM, I end up with 12 by 11, 10 by 11, therefore 14 by 11. That will be my foot to the perpendicular automatically. Now, distance between A and 1 is equal to AB. Apply distance formula. I end up with 12 by 11 minus 1 the whole square plus 10 by 11 minus 0 the whole square plus 14 by 11 minus 1 the whole square. After taking LCM and simplifying, I will get root of 1 plus again 1 plus 9 whole by 11. This will get reduced to 1 by root 11 units. Now, while you think about image, extend AB to C such that AB is equal to BC. Now, C is the required image. C is the required image. Let C be x1, y1, z1. To find this image, I have to proceed further. Till then, I will explain this concept once again. I assume the given point to be A101. Given line is x minus 1 by 1 equal to y minus 1 by minus 1 z minus 1 by 3. General point here is k plus 1 minus k plus 1 equal to k means x is k plus 1, y becomes minus k plus 1, z becomes 3k plus 1. For infinitely many real values of k, the point keeps on moving on the line. For some value of k, it coincides with b. The significance of b is b is the foot of the perpendicular from a to the given line 1. Now dr of line AB or vector AB, either way, right? K plus 1 minus 1, minus k plus 1 minus 0, 3k plus 1 minus 1. Here 1 gets cancelled, 1 gets cancelled. K minus k plus 1, 3k. dr is the given line 1 minus 1, 3. Therefore, by condition for perpendicularity, I get k into 1 plus minus k plus 1 into minus 1 plus 3k into 3 is equal to 0. Therefore, by mistake I wrote 3k plus 1 at the beginning. Anyway, I corrected. K plus k minus 1 plus 9k is equal to 0. 11k is 1, 1k is 1 by 11. Therefore, foot of the perpendicular B becomes 1 by 11 plus 1 minus 1 by 11 plus 1, 3 by 11 plus 1. After taking LCM, 12 by 11, 10 by 11, 13 by 14 by 11. Now, this is my foot of the perpendicular. You could write foot of the perpendicular is, instead of writing B, you can write foot of the perpendicular. Distance AB is distance between line and the point A. Now for apply distance formula, 12 by 11 minus 1 the whole square plus 10 by 11 minus 0 whole square plus 14 by 11 minus 1 the whole square. 12 minus 11 is 1 square by 11 square plus minus 1 whole square by 11 square plus 3 square by 11 square. Therefore, this will become root 11 by 11, which is 1 by root 11 units. Now, the real meaning of image is extend AB to C so that AB equal to BC. Okay, now C is the image. I assume C to be x1, y1, z1. I need to rub this side, then only I'll be able to proceed. Now, how to find x1, y1, z1? Just see here. What I will do here is, this is my C. B is the midpoint of AC. Therefore, by midpoint formula, x1 plus 1 by 2 becomes 12 by 11. y1 plus 0 by 2 will become 10 by 11. Now z1 plus 1 by 2 will become 14 by 11. Therefore, x1 plus 1 becomes 24 by 11. y1 is equal to 20 by 11. Now z1 plus 1 to b is equal to 28 by 11. Therefore, x1 becomes 24 by 11 minus 1. y1 becomes 20 by 11. z1 becomes 28 by 11 minus 1. Therefore, which implies x1 is equal to, after taking LCM, it will become automatically, what do I get finally? 13 by 11. Yeah, correct. 13 by 11. y1 is 20 by 11 and z1 becomes, after taking LCM, 17 by 11. Therefore, image now becomes automatically, the image here will be, let me write here, 13 by 11, 20 by 11, 17 by 11. That is the image accordingly of A with respect to the given line. With respect to the given line, in the line, both are same, I already told you. Let me just repeat the whole process. Extend AB to C so Z. I explained from here. So that AB equal to BC. Now C is the required image. I assume C to be x1, y1, z1. Now B is the midpoint of AC. Now apply midpoint formula. x1 plus 1 by 2 will be is equal to x coordinate here 12 by 11. y1 plus 0 by 2 is equal to 10 by 11 y coordinate. z1 plus 1 by 2 is equal to 14 by 11 z coordinate. x1 plus 1 is 24 by 11. Cross multiply 2. y1 is equal to 20 by 11. z1 plus 1 happens to be 28 by 11. Take 1 to the other side and for both x and y coordinates. Now for 24 minus 11 is 13. 28 minus 11 is 17. Therefore 13 by 11, 20 by 11, 17 by 11 will be the corresponding image. So this is a lengthy problem. It took almost 20 minutes. As I used to tell you in the other videos, if there is any correction, I'll make the correction. Otherwise, it will be uploaded as it is. Thank you students for patient watching. Only this particular problem, you try to understand. Here it is a little bit slanting. You better draw it out as perpendicular here while you draw. Okay, it's a little bit slanting. You can draw it out as a perpendicular line. Okay, draw it out as perpendicular line. Okay, doesn't matter. Okay, I took it as dotted line because those are all not in a flat plane, it will be in space, therefore I took it as dotted lines. Thank you students for patient watching.